This video is about determining graphically the equilibrium constant of a reaction. By following the concentration time graph of a reversible reaction until an equilibrium is reached, we can determine the equilibrium constant, Kc, of the reaction. Let us look at this example. From the concentration time graph, we can know the variation in concentrations of all the species involved in the reaction with time. In this reaction, 3 species, A, B, and C, are involved. First, identify the reactants and products of the reaction. From the graph, the concentration of A decreases with time. Therefore, it is the reactant of the reaction. On the other hand, the concentrations of B and C increase with time. Therefore, they are the products of the reaction. After that, identify the time at which the equilibrium is reached. When the equilibrium is reached, the concentrations of all the species involved remain unchanged. From the graph, this reaction has reached the equilibrium at the second minute. Then, find the change in concentration of each species and hence deduce the chemical equation. For A, its initial concentration is 1.0 mole per dm cubed and its equilibrium concentration is 0.8 moles per dm cubed. Its concentration decreases by 0.2 moles per dm cubed when equilibrium is reached. For B, its initial concentration is 0.5 moles per dm cubed and its equilibrium concentration is 0.6 moles per dm cubed. Its concentration increases by 0.1 moles per dm cubed when equilibrium is reached. For C, its initial concentration is 0.2 moles per dm cubed and its equilibrium concentration is 0.4 moles per dm cubed. Its concentration increases by 0.2 moles per dm cubed when the equilibrium is reached. The ratio of change in concentrations of A to B to C is 2 to 1 to 2. This shows that when 2 moles of A reacts, 1 mole of B and 2 moles of C are produced. Hence, the chemical equation of the reaction is. Now, write the expression for the equilibrium constant for the reaction. B and C are the products of the reaction. Write their equilibrium concentrations as the nominator. The stoichiometric coefficient of C in the balanced equation is 2. We have to add the power 2 to the equilibrium concentration of C. A is the reactant. Write its equilibrium concentration as the denominator. The stoichiometric coefficient of A in the balanced equation is 2. We have to add the power 2 to the equilibrium concentration of A. Finally, substitute the equilibrium concentrations into the expression for the equilibrium constant. We get the value of 0.15.